इस वीडियो में हम जानेंगे मैग्नेटिज्म के सब टॉपिक्स जैसे कि मैग्नेटिक फील्ड ऑफ वायर एंड कैलकुलेशन ऑफ द मैग्नेटिक एट अ कांस्टेंट वैल्यू। ये आपके डे टू डे लाइफ में यूजफुल होता है, जैसे कि सिक्योरिटी डिवाइसेस, ऑडियो स्पीकर्स, मेजरिंग द कंपास डायरेक्शन। While beginning this video, I want you to observe the video and understood the purpose of this video, which I will show you now. Take a magnetic compass below the wire and it has to be parallel. Take a 9-volt battery and connect with connector, make it easily. Connect the battery. The circuit to the cable has to be connected, and you can see now the needle of a compass is moving. The main purpose of the video was to know that the wire generates a magnetic field around us. Now a man has taken a wire and a battery. This battery and a compass. The battery is a plus and a minus. You have put like this. The wire you have connected to it. Now the flowing of the electrons are flowing and the magnetic needle start moving. Means this shows that the wire creates a magnetic field around itself. This was described by the scientist a great physicist Hans Christian Oersted in 21st April 1820. Okay, hence we can see in the 19th century also. Observe the image and understand its purpose. You have observed the image well. Now understood the purpose of the image. The purpose was the image was to how to determine the direction of the magnetic field. For the example, I have a wire. The electrons are flowing from downwards to upwards. To determine that the direction of the magnetic field, so take your thumb, put here, and means you put your finger in a circle form, a circular form. So we get that the magnetic field of the wire means the electrons are generated. So the magnetic field is in a anti-clockwise. Now the second example, if I am taking the wire like this and the electrons are flowing like this, means upward to downward. So I have to put the direction. मेरे को direction change करना है. I have to change the direction. So the thumb has to be here and the finger was to go inside. So we get that in the upwards to downwards, the electrons which are flowing, the magnetic field is in a clockwise. FAB represents a current element of a conductor PQ carrying current I and R. The position of the vector of P from the current element is B. Then the law states of the magnetic field is dB. Now we are going to study that how we can find the constant magnetic field that wire is creating. Okay. Now for the example, here is a wire and I am taking the small element color, means current, small element current. I am denoted with DL. It's a vector quantity. And from this place to this place means I am removing the P point ka magnetic field. So it can be constant value, and here's the R. The distance with it is denoted with R. For the now the angle with it is a theta. It's a theta. Now a dB it is. Means why I am taking dB, because d is a small element of the wire. To denote with the magnetic field, I am taking the b. It's a vector quantity, all they are vector quantity. Okay, so dB is inverse, is directly proportional to I. Again, dB is directly proportional to dl. dB is again directly proportional to sine theta, and dB is again directly proportional to 1 by r square, means is the distance. For while doing this solve, we get the formula in a vector form. dB means dB in the vector form mu naught by 4 pi I dl in a vector form into r pi r in a vector form upon r cube. To change into the scalar form, we need there is a process while I am doing in this to form to a scalar form. Okay, dB while its magnitude equals to mu naught into 4 pi by I dl and r. Okay, and the r is here, so the r is cutted with r cube and sine theta here, r cube. Okay, now here is dB in a scalar quantity. This is a full in a scalar quantity, so it will become dB equals to mu naught by 4 pi I dl sine theta by r square. I hope you will be understanding that what I have teach in this video. Okay, thank you. Thank you for watching the video, and please like, subscribe and comment.